Hey everyone and welcome! Today I want to share with everyone everything I know about content management system or CMS or how I like to call it, Git. So first of all, why should you be interested in content management system? Well, I've talked to programmers recently that still back up their stuff on their computer by making copies of the same folder over and over again. And I've seen artists lose hours and hours of work just because their hard drive crashed. And all of this can easily be avoided nowadays with something called Git. Now, there's other content management system out there. I've used Subversion for a really long time, and I've used Perforce also at one of the companies I've worked at before. And honestly, I don't think they're that much different, but Git just has all these tools that come with it and these free system to back up your stuff on the cloud that I think it's really the best choice for anyone right now. If you're starting and you want something really simple, you might actually be better off with Subversion because it's a very simple content management system. But I think Git has a solution for everyone. The first time you look up Git on the web, you're gonna read a whole bunch of stuff you're not gonna understand, and it might give you the feeling that Git is really complicated and really difficult to use, but that's not the truth. Basically, all it does is keep a history of a bunch of files. Where it's really powerful is that it can do a whole bunch of stuff with that history. But first and foremost, you don't really need to do anything with the history. But if you need some collaboration, or if you need to copy this history to multiple machines, and then you need to put all this history back together in one single big project, well, it can do all of this for you really easily. Now let's just go step by step and start easy. The first thing you'll want to do is download the Git command line utility. Git by itself is just a simple command line tool that you open a prompt in Windows or Linux or anything you want, and then you just type some command to tell it what to do. So once you've downloaded Git and you've installed it on your computer and it's in your path so that you can access the command line from anywhere, the first thing you do is you go into your favorite folder where you have a bunch of files that you would like to start keeping track of the history, and you create a new project. This is done really easily. All you have to do is type the command git init in a folder that you want to start tracking history, and it'll just initialize the Git system inside this folder. Now, after that, what is important is you have to tell Git which file you want to back up. And to do that, again, it's very easy. You either type git add the name of the file, or you can type like something like git add star, where it's gonna add every file in your folder. And when you're happy, you can check which file are going to be tracked in the history by doing something like git status that will show you all the files that will be added into the Git repository. And when you're satisfied with it, you can type something like git commit -m for message, and then type some kind of message to remember what this history is all about, and then enter, and you're done. Basically, you started tracking the history. Now, when you modify a file, you type git status. It's going to show you the file that have been modified on your local computer and that haven't been committed to the Git history. You can do, again, a git add and another git commit every time you want to update the history of the file. Basically, you do a commit every time you want to keep a backup of your files. And well, considering how easy it is, I really recommend you do it all the time. Now, if you want to check the history of previous file, then you can check the log by typing git log. And that's gonna show you all the previous commits you've done. Now, when you want to start doing a little bit more stuff with your history, the Git command lines start being a little bit cumbersome. It's time to install some graphical user interface tools to help you. Personally, I use two different software to manage my repository because I've found that neither of them has everything I want. The first one is something called TortoiseGit, and it comes from Tortoise SVN, which was the Subversion version of it, and it has amazing tools for checking and tracking the history of a single file and doing commits with TortoiseGit is really simple and easy and straightforward. But for some of the more advanced stuff in Git, I find that the software called Fork is much better. If you really just want to install a single tool, then I would probably recommend Fork above TortoiseGit. Fork is definitely one of the best tools for Git that I've ever seen. The next step is to back up everything onto another machine. Because right now, all your history is still local, and if your computer dies, then you have a big problem. So the best solution is just to copy all of this into some server on the cloud. And to do this, Git already comes with something, and it's called a remote server. And to send stuff to the remote server, what you do is something called a Git Push. Now, I'm familiar with two services that provide remote servers for Git. One is called Github, and the other one is called Gitlab. In my opinion, both of them are pretty much the same. If you are willing to have an open source project, GitHub provides more functionalities to projects that will have public repositories. What public means is that everyone will be able to see your files, but it doesn't mean that people will be able to change your file. You're still the only person allowed to push to the server, but if someone wants to copy your project and do something else with it, then they're allowed to do that. But if you're willing to do that, GitHub has a few more features than GitLab. But if you want a private repository, then both of them are pretty much identical, I think. That said, if you have a really big project and you're planning to have a lot of people contributing to it, then probably you want to have a look at all the features that each of those services provide, like build servers, issue tracking, pull requests, group management, and all that. But if you're just a small project, then just go with whichever you feel like. So once you've created a free account on your platform of your choice, what you do is click the button to create a new project, and you name your project whatever you want. For example, let's say YouTube test. Then once you click OK, it's going to give you a URL like github.com/ombarus/youtube-test.git. And then you take this URL, you open your command line again, and you type git remote add origin and the URL you were given. Now, what this does is that it tells Git that there is a remote server where you want to copy your file called origin. So the origin in the command I just gave you could be anything. You could call it remote one or GitHub or something. And then when you want to copy your history to the server, you just type git push -u origin master. And that's going to take everything and copy it onto the GitHub server. And then you have a really safe backup. Now, you can commit as many times as you want, and once in a while, when you're ready, you can push all your changes to the remote server. You don't have to do it every time, but I think it's a good idea to usually do it all the time. Now, if you're like me, a solo developer, and you're working by yourself, or if you're an artist or a game designer and you just want to back up some stuff on the web, then you're all set. But if you want to work in collaboration with a bunch of other people, then you'll need some of the more advanced features of Git. And the two most important features are branches and merge. To understand branches and merging, you have to put yourself in a situation where you're working with a bunch of different people. Let's say we're students and we have to work on a project in groups of 5, and the teacher gives us some GitHub repository with the base project, and we have to implement some new features on it. Maybe we divide the features between all 5 of us, and everyone starts working on their own features. Now, one of the things that's going to happen is that, for example, I'm not finished working on my feature, but maybe it takes a couple of days, and I want to make sure I keep a backup of this work in progress. So what do? Well, you add the file that you change, you commit the history, and then you do a git push origin master to send it to the server to backup. Now, the problem is, let's say that the teacher tells you that there's a newer version or something, that he fixed a bug, and you have to get the latest version from the server. So all your friends are going to do a git pull origin master, which is going to bring the changes from the server into their local version so that they can keep working on what they were working on. The problem is that you've also pushed changes that weren't ready to be used, and now people are stuck with all your broken shit. So what can you do then? Well, enter branches. So the idea is that you don't have to have only a single history on your server. You can keep copies of different histories that evolve like completely different projects. The reason they're not different projects is that GitHub can do some magic stuff and merge branches together later when you're ready. So to create a new branch, what you're going to do locally is something like git checkout -b for branches and the name of a new branch. So the default branch is always called master. That's why when you were doing pushes, you were doing git push origin master, because master is the name of the branch. So once you've done something like git checkout -b my branch, well, what you've done is you've copied your history into a new branch. So everything that you haven't pushed to the server is now in a new branch, and you can do git push origin for the server and the name of my branch. And this is going to create like a new project inside your project, and people can switch between different branches. So you can do git checkout my branch to go to your branch, but if you want to, for example, check out one of your friends' branch, then you can do git checkout my friend's branch, and you still have your changes in my branch, but now you're using your friend's branch for a little while. And when you're ready, you can switch back to your branch very easily. Now that's where fork is really nice, because instead of having to type all these commands and remember the name of the branches and all that, you can just look at the list of all the branches in fork and you can double click on them to switch to one branch from another. And usually it's nearly instantaneous, and it's gonna just back up your file and bring them back whenever you need. And when you're ready to actually send it to all your friends, when you're finished working on your branch, what you do is that you merge your branch back into the master. And you don't have to merge it in master. You can merge in between branches. You can do all sorts of things. But the main one usually is merging your branch back into master. And to do this, once again, I suggest you use fork. You check out the master branch. You make sure you're up to date. And then you just right click on my branch and you select merge into master. And that's going to take all your changes in your branch and bring them into master. And then you push master to the server and everyone can enjoy your new changes. So far, so good. But now comes the less fun part. Git is famously amazing at merging branches together. It does an incredibly good job of knowing how to combine two branches together to make it work. But sometimes even the best automatic system will fail, and then you're gonna have to do it yourself by hand. So what that means is that maybe you and your friends ended up changing the exact same file and the exact same text, but you changed it differently, and now Git doesn't know what to do with it. So it's going to tell you when you try to merge that it cannot merge because there's a conflict that needs resolving. This is where fork comes in really handy, because it offers a way to compare different versions of a file so that you can manually edit it and resolve the conflict yourself. And then when you're finished, you click on resolve, you commit the file, and then you can complete the merge and you can send it to the server. There's no way around it. It'll happen sometimes, and it's just very painful when it happens. But there are some things you can do to try to avoid this issue. Which brings me to my last point. Git is just a tool, and like any tool, it can be used in very, very many different ways, and some might be better than others. So here's a few of my personal recommendations. They're not things you have to do, but I highly recommend you think about them. First, think carefully about your commit message. Git has a whole bunch of ways to check the history of a file and to look at what changed between two history. One of my favorite tools is using TortoiseGit to blame a specific file. What this does is that I can see the commit for every line of code in a single file, which is awesome. But if every commit message is something like added file 1 or removed file 2 or deleted file 3, then it's pretty much useless, because Git already tells you what changed. What it doesn't tell you is why it changed. So make sure that your commit message addresses why you changed something. Now, as your project grows, what you're going to want to do is make sure that you create a branch for every single feature you want to add in your project. And you're going to want to name your branch something meaningful, like MC rig update. And then when you're done working on that branch, you're going to use fork to merge back this branch into your master, and you're going to delete the branch Don't worry, it's still in the history, it's just not active anymore, so you're not gonna see it in fork or in GitHub, and it's not gonna pollute your repository. Now, getting even more advanced, if you're starting to have a really big project and you're working on a branch for a really long time and master is moving ahead of you really fast, don't just merge master back into your branch when you want to get the latest changes from everyone else. That can cause some issues with the history later on that's going to be a little bit tricky to resolve. What I suggest is that you have a look at the command called Rebase. Now this is a very advanced command and it can create some issues by itself, but if you're working for a long time in a branch and you want to update from master, then I would really recommend you use this. To make a long story short, Rebase is basically the same thing as merging, except it changes the order where the changes are going to be applied. Right? When you do a merge, basically it takes your changes and it applies them on top of whatever is in the other branch. So if you're merging master into your branch, it's going to take everything that's changed in master and put them on top of your changes in your branch. That's going to create some issues later when you look at the history and you're going to see master commits embedded in between your branches commit. If you do a rebase, what it does is that it applies the changes in your branch on top of whatever it was in the master. So it basically append master before the changes in your branch, helping keep everything kind of clean in the history. To be honest, in the end, you have the same result. It's just kind of clearer in fork and in GitHub later when you're going to have to look at the history. Okay, next tip is for really big project. When you have something like Godot engine, you're going to just want to simply lock down the master branch. No one can commit directly into the master branch because everyone will start new feature from the master branch. So if anything is broken in the master branch, then no one can start a new feature. What you're going to want to do is start adding issue tracking, and GitHub and Gitlab provide both very useful tools for doing that. And you're going to want to link merge requests with those issues, and you're going to have team leader handling the merge between the branches and the master. And they're going to do that probably only after doing some peer review or having like a build machine running unit tests to make sure that everything is still working. But this is really like the more advanced, complex stuff, but it's been working for nearly all open source projects out there, so it's, I think, a good way of doing things. Okay, back to more regular advice. My next advice is to avoid committing big binary files to Git. Git is really not made for binary files. It's made to keep track of changes in text data. So like a notepad or source code or something like that. If you have big executable or if you have 3ds max file in the hundreds of megabytes, then I would avoid committing them to Git. Some textures and game data it's perfectly fine, I think, but anything over a couple of 10 of megabytes should probably not go into Git. Now Git has a solution for that. It's called Git Large File System, or Git LFS for short, and I've used it before to store huge files, but I've never had to set it up myself, so all I can say is if you have big files you want to keep inside Git, then have a look at Git LFS. Finally, just like you should think about your game architecture before you start working on it, you will want to think about your file structure to make your life easier while working with Git. For example, if you know you're going to use Git LFS, then you should probably have all of those files inside a single folder just so it's easier to manage. And you should also manage which file Git will see by using something called the .gitignore. This is a file you can put in any of your folders to tell Git to ignore certain files. It's not going to track them, it's not going to register them as change, and it's very useful so that you don't pollute your status log window. So, for example, Krita creates a lot of temporary files when I use it, and I don't want to commit those files, but also I don't want to always see them in the status window of my Git commits. So to avoid this, I have a git ignore that will just ignore these files. And to make sure I never commit any of my executable by mistake, I also have a git ignore on all my executable. And beside that, there's a couple of other things that you can do to help yourself avoid useless merge conflict. For example, try not to move too many repositories and files once they've been created, and maybe try to break your source file is in many small files so that if a lot of people are working on the project, they're not all working on the same file, which means that they're not going to be stepping on each other's toes, which means it's going to reduce eventually merge conflicts. There's many other features that you need to be aware of to really use Git to its full potential, but I'm not going to take the time to go into all of this. They're very situation based, and if you ever get into this situation, you just need to Google it, and it's going to tell you exactly the command you have to use to do exactly what you want to do, whether it's pruning a whole history from your branch, or changing the message on a commit, or changing the author, or cherry picking a single commit from a branch to bring it into your other branch or something. All of these are very easily done. You just need to look up the command to do it in Git, and it's pretty easy. And for now, all I'm gonna ask is that you hit the like button, subscribe, and I'll see you guys in my next episode. Bye!